All right, welcome back. This is 6.4, video number 2. Oh, I don't have a pen going. Video number 2 of 6.4. So first thing we're going to do is we're just going to graph y equals log base 5 of x by hand. All right, so what we're going to do this is we're going to make a chart of values and think about the domain and all that kind of good stuff. So actually to start with, where's the vertical asymptote for this guy? Where is the vertical asymptote? Well, it's where x equal to 0. That one's pretty easy to solve. So that's our vertical asymptote. And the domain is going to be 0 to infinity. And now let's just make a nice chart of values right up here. We'll graph it below. So we're going to pick some x values and compute some y values. Well, there's no point picking 0 because that's not in the domain. So let's pick 1, let's pick 5, and 25. And I'm picking powers of 5. 5 to the 0, 5 to the 1, and 5 to the 2, so it'll make the computation easier. So if x is 5, log base 5 of, if x is 1, log base 5 of 1 is equal to 0. 5 to the 0 is 1. Log base 5 of 5 is 1. 5 to the 1 is 5. And log base 5 of 25 is 2. 5 squared is 25. So we have the point 1, 0, 5, 1, 25, 2. You can see it's a pretty slow growing function, but it's always going to get bigger because you're always going to, if you have a bigger input, you're going to have to put a bigger exponent on 5 to get up to that. And we have our vertical asymptote at x equals 0. So let's go down and graph this guy. We don't need very much in the y, but we need quite a bit of x. Let's count and see what we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Boo. Wish I had one more point. I think I can just squeeze one in. We'll just squeeze one in. I should have made this graph a little wider. That's okay. Here we go. There we go. Yeah, that should be okay. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We're just going to squeeze it. 21, 22, 23, 24, 25. Okay, I'm just pretending it's there. 21, 22, 23. Oh, that's not quite enough. Hang on. Oh, what have I done? Things have gone awry. Okay, I'm changing my mind. I'm just going to go by 2s. I don't know why I didn't just do that in the first place. It's fine. Back up. This is all about doing graphs. It's just not going to fit. It's just not going to fit. So I'm going to go by 2s on the x-axis. And I know I can move it one to the left, but I have a plan. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. I'm going to go by halves on the y-axis. So that's 1, 2, 3, -1, -2, -3, and then 2, 4, 6, 8, -10. All right, and I'm going to switch color here to green to graph this guy. All right, so my first point, oh, well, I have my vertical asymptote, x equals 0. Let's put that guy right down here. So I remember that, x equal to 0. That's my vertical asymptote. And then I have the point 1, 0. So over 1 of 0, that's right about there. I have over 5 up 1. 1, 2, 3, 4, 5 up 1. So that's 5. And then over 25 up 2. 20, 22, 24, 25 is right here. I'm going to go up 2 for that one. And then I know that as I get close to 0, I'm going to shoot down here to negative infinity. So let's just kind of graph it like that. And there's my graph. Not too bad. All right, so that's graphing a basic logarithm. You really can't use a graphing calculator to graph log base 5 because it doesn't have a log base 5 button in any graphing calculator. I know. Desmos might do it. I don't know. I haven't actually checked that out, but it's something I should check out. Let's try using this information to help us find more information. Let's try log base 5 of t plus 2 instead of just log base 5 of t or log base 5 of x, depending on your variable. Well, we know about graph transformations. If we look at this and we compare it to just log base 5 of t, how has this graph been transformed? Well, the plus 2 is happening inside the function. So this is going to be a shift 2 to the left, right? Shift 2 to the left. So what is the domain of f of t going to be? Well, we're going to shift the domain 2 to the left. It was 0 to infinity. Now it's going to be negative 2 to infinity. We're going to shift the vertical asymptote 2 to the left. So x equal to negative 2. So what we're going to do is we're going to find some values for this guy and graph it on our previous graph and do a little comparison. So let's just make a table of values here, and I think I might just go put it on that same graph, t f of t. And the values I'm going to pick are negative 1, and I'm going to pick 3, and I'm going to pick 23. If I put in negative 1, I'm going to get log base 5, negative 1 plus 2, which is log base 5 of 1, which is 0. So negative 1, 0 is a point on this graph. If I put in 3, log base 5 of 3 plus 2, log base 5 of 5, which is 1. So that's the point 3, 1. Log base 5 of 23 plus 2, log base 5 of 25, which is 2. So I get 23, comma 2. Let's switch to a different color to graph this guy. Let's make him pink or something. All right, so let's go plot the points negative 1, 0, 3, 1, 23, 2, and remember that a new vertical asymptote is at x equal to negative 2. Let's go back to your other graph and put it right on the same one. All right, so I'm going to go to negative 2, which is right here. I'm going to put my new shifted functions, vertical asymptote. So this is at x equal to negative 2. And I have the point negative 1, 0, negative 1, 0. So that's exactly 2 to the left of this guy. I had the point 3, 1. 1, 2, 3, 1. And again, 2 from this guy. And 23, 2, which is going to be 22, 23. It's kind of hard to tell because this is not very much of an increase, but it's slightly below that, which is exactly 2 from this guy. So I'm going to graph the shifted graph in pink here, try and hit the pink points. It's going to be just slightly over this one the whole way along. There you go. All right, so that's how you do graph transformations with logarithms. So let's just talk about the general rules here. Much like they were before, if you have a logarithm, log base b of x, a transformation is going to have the form a times log base b of x plus c plus d, with our stretching and compressing being the a, with our shifting left and right being the c, and our vertical shift up and down being the d. And the same rules apply for reflection, right? The log, if you have the inside, that's going to be the parent function reflected about the y-axis. If you have the a less than 0, that's going to be the minus f of x. That's going to be shifted across the x-axis, so a vertical shift. So all the same rules apply that they applied before. So let's do one example of this and see if we can figure out the transformations and create a table and graph this function. All right, so we're going to graph f of x equals log 6 minus x plus 2. So let's list all the transformations for this one. All right. So the first one, I think the easiest one to spot, is the plus 2. And so that's a vertical shift up 2. And then we have the 6 minus x. So we're going to write that as x plus c, sort of. So let's rewrite this. F of x equals log. I'm going to write this as minus x plus 6 plus 2. All right, so the minus x in there, that's going to make me reflect across the y-axis. So a reflection across the y-axis, and then we're going to shift 6 to the left, right? Because it's plus 6, so shift 6 to the left. All right, what's the domain of f of x? Well, I like actually answering question C first. I'm going to solve where 6 minus x equals 0, and that's when 6 equals x, right? So my vertical asymptote is at x equal to 6, and that means my domain goes from minus infinity up to 6, right? Minus infinity up to 6. Since I did a vertical a flip across the y-axis, my domain is going to be switched from going from negative infinity up until 6. And again, we could quickly test that. If we plugged in a value like 0, we get log of 6, which would be okay. If we plugged in a value of like 10, we get log of -4, which would not be okay. Kind of verify that in your head. And so let's create some tables and try and graph this guy. All right, so what values do we want to pick here? How about we pick 5? And log of 6 minus 5 plus 2 is going to be the same as log of 1 plus 2. 10 to the 0 equals 1, so that value is just going to be 2. So 1 point on there is 5, 2. And let's see if we can figure out another point. Let's see. Let's pick -4. Log of 6 minus -4 plus 2 is log of, I'm not going to have space in my graph to graph this guy, log of 10 plus 2. Well, 10 to the 1 is 2. 10 to the 1 is 10. So that's going to be 1 plus 2, which is 3. And the next one is going to be hard to get another good one because I don't have any more good powers of 10. So let's just use these. And we know my vertical asymptote is at x equal to 6. So let's try to graph this guy here. Let's put the graph right here in the middle. All right, and we're going to go to 6. 1, 2, 3, 4, 5, 6. And that's going to be my vertical asymptote. And we have the point over 2 up 5. 1, 2, 3, 4, 5. I mean 5 up 2. 1, 2, 4, 5 up 2. We have 1, 2, 3, 4 up 3. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. And so I think that this is enough to graph our value with. What we could do, we're missing quite a few points. Let's use our calculators to help us a little bit here. Let's plug in log of 0 because this really isn't giving me a good enough graph. So we need a few more points. We'll have to use our calculators to do some approximations. So let's plug in 0. I'm going to pull my calculator out and I'm going to plug in log of 6 minus 0 plus 2. So that's going to be log of 6. And I'm going to get an approximation because I need some more points here. Log, oops, I didn't hit a 6 first. 6 log plus 2. And I get about 2.78. I'm going to call that 2.8. And so at 0, we're going to be at about 2.8, which is about here. And that makes me feel like we're filling this in a little better. And let's maybe put 1, 2, 3, 4, 5. I think it'd be useful if we did like 5.5 to get a feeling there. So we can go, as long as we're using our calculator approximate, we can plug in 5.5. So log of 6 minus 5.5, compute the log and add 2 to that. 6 minus 5.5, oops. Oh my gosh, can't keep bumping the wrong buttons on my phone. 6 minus 5.5 equals 0.5. Take the log base 10 of that, add 2 to it, and we get 1.7 about. 1.7. I think that's going to help a little bit. So at 5.5, we're right here at about 1.7. So I think we can feel like, let's draw the graph in blue so we can see it a little bit better. We're shooting off here for our vertical asymptote coming up, and then we're slowly increasing like that. So there's our graph. All right, so let's go ahead and go to Desmos, and we're going to use Desmos to help us make sure that our graph is correct. All right, here we are in Desmos, and let's go ahead and try and check our example 5 graph, which is also practicing using Desmos. So we're going to type in f of x equals log, and Desmos knows that space 10, 6 minus x, end your parentheses plus 2. And what's kind of cool about Desmos is that you can actually type in and check out your ordered pairs that you created. So I'm going to put in a parameter a, just a letter to represent any value, and then f of a. And then, yeah, I do want to add a as a slider, and I want to label it. And now what this does is that you can move A around and it tells you all the points on your graph. This is a nice little tool. And you can also plug in values for it. So if I wanted to check my first value, which was 5, I just hit enter. And it tells me my first point was 5, 2, which is what we got. You can slide it to -4. You can just type it in. -4, 3. We also got 0. And we got about 2.8, same. And then we also put in 5.5. So this can help you with your graphing as well by plotting some points for you. All right, that's it for this example. Let's go ahead and try one more of these guys. All right, and welcome to video 3 for section 3, 6.4, section 3, geez. Video 3, section 6.4. And we're going to do one more of these where we list the transformations and look at the graph, and then we're going to try to match the function to the graph. So let's do one more of these. I want you to try this one on your own first. So the first thing I want you to do is list the transformations for G of W. So right now, pause the video and list all 3 transformations, find the vertical asymptote, and figure out the domain. All right, are you back from doing all those things? Let's go ahead and do them together. So let's list the transformations. Well, I see a vertical shift down 3. I see a horizontal shift right 1. Left 1. Sorry, I don't know what I was saying. Left 1. And I see, well, it's negative. So that means it's reflected across the x-axis. And it's a factor of 1/2. So the absolute value is less than 1. So that's going to be compressed vertically by 1/2. Okay, so those are our transformations. What is the vertical asymptote? Well, remember that's where we look inside the argument to natural log. There's so many circles on here you can't even see it anymore. But inside here, we're looking at the w plus 1. So I'm going to solve this. W plus 1 equals 0. W equals -1. So my vertical asymptote is at -1. Vertical line at -1. And my domain is going to be from -1 to infinity. All right, let's double check that if we plug in a 0, we're going to be fine. If we plug in a 2, we're going to be fine. Yep, that's definitely my domain. And so it says create table, but sometimes at this point, I think we can just use technology to help us. So let's go ahead and head over to Desmos and let's look at the graph. We know what we're expecting is going to be reflected. It's going to be shifted left 1, down 3, and we're going to be a little bit compressed. So let's go ahead and go to Desmos and see what it has to say. All right, here we are in Desmos. Let's try and graph this guy. All right, so G of W equals -1/2 natural log, parentheses, W plus 1 inside the parentheses, minus 3 outside the parentheses. All right, did we have a vertical shift down 3? Yeah, looks like we're down 3. And left 1, that looks pretty good. Compressed vertically by 1/2, sure. And reflected across the x-axis. Yeah, it's definitely going down, decreasing instead of always increasing. So there is the graph of our function using Desmos.